Hi there, my name is Hiroki Mori. Today I will talk about pitch contour separation from overlapping speech. Our daily conversations never take place in a recording studio. We have conversations at home, in the office, in restaurants and cafes, indoors and outdoors. Analyzing and modeling the prosody in everyday conversation is therefore challenging. In such environments, it is difficult to record each participant's voice separately. If the separation is incomplete, the other participant's voice will intrude the target speaker's recording, resulting in overlapping of the speech. The overlaps make the pitch extraction inaccurate. Therefore, the goal of this study is to separate each speaker's pitch contour from an overlapping speech in conversation. In this study, we assume a single-channel recording. We further assume that speaker identities are known for given overlapping speech. In addition, presence or absence of each speaker's utterance, namely voice activities, are assumed to be known, which is a reasonable assumption for most conversation corpora. The proposed network consists roughly of an encoder and a decoder. The encoder converts the spectral pattern of each frame into pitch features. The output of the encoder is then combined with the target speaker's embedding and voice activity information. The decoder receives it and outputs the sequence of discrete FO and VUV. In the network training, utterances of two speakers are sampled from a training corpus. Before mixing, the ground truth FO of each utterance is estimated by making use of a pitch extractor. Then, the two waveforms are randomly shifted and mixed, which simulates an overlapping speech in conversation. The mixed speech signal is converted to a spectrogram and fed into the encoder. The loss calculation is performed speaker-wise. For each speaker, the embedding and voice activity is concatenated with the encoder output. The decoder estimates the speaker's FO contour from all of the information. Because we already have a ground truth FO of the speaker's utterance, we can calculate the loss for the speaker. The process is repeated for the another speaker. The total loss is calculated by summing up the losses for the two speakers. For the experiment, we use the corpus of spontaneous Japanese. The subset we used consists of monologue speech. FO estimation was performed with the Yang-Saf algorithm. The spectral information was obtained from the mixed speech, which served as a log-amplitude linear spectrum. The encoder consisted of 32-channel 16 by 1 convolution plus value plus 2 by 1 max pooling. The decoder consisted of a bi-LSTM plus dropout plus a fully connected layer. The speaker embeddings were 16-dimensional vectors. I will show the distribution of the learned speaker embeddings mapped to a 2D space with PCA. You may notice the clear separation of female and male speakers. The first principal component turned out to be the overall pitch height of the speaker. Here I will show you some examples of the pitch contour separation. Please listen first to the mixed speech.
境界のある場所。
どうなんだろうと。
どうなんだろうと。境界のある場所。These contours were estimated from the original waveform before mixing, and these panels show the estimated FO contour for each speaker. Incredibly, this final rising tone has been successfully preserved with the proposed method. Let's move to the next example.
ヒノ
で私
キの
にとっては、
ヒノキの私にとっては Two F4 contours of female and male speakers are interwoven. For this example, they are successfully separated as well. The ground truth F4 includes a pitch doubling error, but the proposed method even corrects the error, possibly due to its ability of modeling reasonable pitch shape. Here I will show an example of two male speakers.
じっくりと書きを
という
眺め、
ことで、
As you can hear, two pitch contours are very close. However, my method works quite well even for this case. This table shows a quantitative evaluation. No separation means simply applying the pitch extractor to the overlapping speech. With the proposed method, the voicing decision error and gross pitch error was drastically reduced. Currently, I use the simulated overlapping speech for the evaluation. The next goal is to apply this method to real conversation corpora. But there exist several problems to solve. Here, I will show a very preliminary result. The method was applied to the corpus of everyday Japanese conversation. Here, two speakers are speaking simultaneously, and I want to estimate the pitch contour of the left speaker from the waveform recorded by his IC recorder. Please listen to the waveform.
塾って言っても
The target speaker said, 塾って言っても. The middle speaker's utterance, あー、なるほど, overlapped to the target speaker's utterance. So, a simple pitch extraction erroneously detects the non-target speaker's efforts shown in this figure. On the other hand, when applying the proposed method, some parts of the original F4 contour were successfully captured. At the same time, it produced some spurious F4s or failed to capture the F4. I am now working to improve the performance.